Hi there, everyone. Welcome to the Headwinds and Tailwinds inside of Aerospace and Defense webinar. I am going to start with a round of quick intros. I'm Caitlin Curtis. My background is in aerospace and defense, new product introduction and manufacturing. And here at Instrumental, I work on enterprise systems deployment to help folks with those specific issues inside of aerospace and defense, scaling up operations and the like. Jason, what is your background and your introduction?
Hi, I'm Jason Scabaris. I'm the president of the Saline location of Emerald Technologies. I've been working with A&D companies on the EMS side for over 20 years, and have been in this president's role for about the last 5.
And how about you, Ben?
Hi, Ben Walker. I'm a partner at Kearney supporting a lot of our aerospace and defense work, particularly with industry partners, and been doing here about 10 years. And prior to that was at Lockheed Martin. So entire career in the aerospace and defense industry and love it.
Yeah, how about we close out with you, Chris?
Hi, I'm Chris Moyer. I've got over 30 years experience in the industry, over a decade of that in aerospace and defense, at most of that at Aerojet Rocketdyne, a little bit at Northrop Grumman, and some time at Blue Origin and some time at Williams International. I've worked on a number of aerospace and defense programs, and I'm now currently actually at one of our instructors at IPC teaching the courses on print circuit board design, manufacturing, those things, but with a course specifically focused on military and aerospace design, as well as other aspects.
Excellent, perfect. Well, to kick off on kind of questions, as we've all kind of seen in the last few years, with global conflicts on the rise and defense budgets really shifting in that direction to support that initiative, we're seeing more demand for advanced systems like drones and surveillance. How have you guys seen this open up revenue opportunities for electronics manufacturers, and where do you see that market really heading? And Jason, I think I'd love to start with you.
It's one of our fastest growing sectors for sure. Everything at Emerald is on the high reliability side, but A&D has been growing faster than most. All the different drones and unmanned systems that have been created over the last decade or so have really blown up, and yeah, they continue to be our fastest growing sector.
Yeah, and how does that change in volume change the way you guys are working with these folks, or where you see the market heading?
Yes, so it pushes us to continue to upgrade our technology, right? So there's some of the most challenging circuit boards to make. They're going to have the tightest tolerances and the highest specifications using the latest and greatest electronics on their circuit board. So making sure we're investing heavily in our CapEx side of our business to make whatever is brought to the table from the next opportunity, we're able to handle it.
Got it. And Ben, how do you see folks, to expand on that, how do you see folks kind of like pivoting to accept these new volumes and these new market challenges?
Yeah, I think there's a couple things at play here. Everything has electronics in it, of course, and it's even progressing further into that way, especially as we think about protected communications and anti-jam technologies and those type of things. I think the thing that people are wrestling with is how do you take like even US centric designs and broadening them to be able to be applicable to international customers. You're seeing folks in Europe particularly, and some in Asia really increasing their defense spending for a lot of these units, and being able to buy exquisite technologies that or request exquisite technologies from the US that they haven't before. So how do you make ITAR free designs or things that are exportable here to be able to really capture additional market share in this space?
Yeah, and with that shift to kind of like different, like almost like a different and larger market, do you see kind of folks pivoting in any direction on the production side, or any new kind of variables being introduced for them?
I think just being able to handle the complexity of it all, being able to switch things in and out quickly, do fast changeovers on the lines, modular designs to be able to handle those things, to be able to have different security qualifications, in the same place, are really where we see a lot of that investment going. So those are big opportunities for these companies. You know, if you listen to any of the earnings calls, you know, they all really like this international opportunity because it's a better opportunity to gain margin. So being able to invest in the right areas to be able to do it without compromising their ability to deliver for the US government is key.
Got it. And Chris, how do you see these implications on like volume and market really hitting you guys?
Yeah, so that's one of the areas, and to piggyback onto what Ben and Jason said, one of the challenges we're having that I'm seeing from the user side of things is as we increase in these volumes, right? With how do you achieve the high reliability that we're used to in traditional mil aero designs that take lots of qualification and testing and validation at the end of the production run, the inspection, and so on, and ramp that up to the type of volumes demand. So not only in the new product design, but we're also seeing depletion of existing stores of munitions and products that have been around forever, and we're now needing to ramp up volume on all those. And so again, as Jason pointed out, there's a lot of investment that needs to happen in capital expenditures and so on in order to ramp that volume production back up to meet those type of quality and design needs in addition to the new technologies.
Yeah.
Yeah.
Can I add in too, like from the supply chain side, we all went through this global supply chain crisis 3, 4 years ago. And one of the things that everybody's taking about is as we're ramping, a lot of the materials needed for some of these devices are coming from overseas markets that are less friendly governments now. And as the climate continues to change, how do we move that supply chain to a more reliable place that we know if we need to continue to ramp volumes, they're going to be there?
I think the things that a lot of our clients are wrestling with is, especially for those of us that have been in the industry for a long time, is it's always cyclical, no matter what, like these big ramp ups and then ramp downs. And what's the right amount of investment for this? Because you see like folks like Anduril putting in, you know, $1 billion practically in this giant facility in Ohio, and others just aren't doing that to ramp the capacity in the same way. So they're trying to stretch and find capacity with the assets they have, and frankly, getting out of some of the, we'll call it like lack of good process that they've been able to get away with in the past, and actually improve throughput with limited capital in that place. So there's definitely a balance in finding that right balance and kind of where you want to place your bet and how long this is going to last.
Yeah.
Yeah, perfect. Kind of on that same trajectory, just seeing newcomers like, you know, the Andrils of the world and kind of like those elements of like a founders fund ecosystem coming up within that commercial space in those similar ones. How do you advise people to think kind of like how do you see established players thinking versus those newcomers, and kind of like what are the different ways that you see established players either pivoting to the current moment or pivoting to the current cohort of players that are coming in? And Ben, I'd love to start with you.
Yeah, I like to say it's variable, right? I mean, if you look at what the world is buying right now with the drones and things that are higher volume, that are frankly less complex. I mean, they're very complex items, don't get me wrong, but you know, they're not an F-35, they're not a submarine, or things that are multi-billions of dollars, you know, single systems with lots and lots of features to it. So that high CapEx investment model works for the drone space, but it doesn't necessarily work for those other platforms that have super high complexity, low volumes, you know, that type of thing. So I would say the folks that kind of believe their space is the high complexity, low volume area, you're not seeing a ton of reaction to what's happening with Anduril. I think the folks that make autonomous systems and things that are competing with them in those spaces, you're looking at them try to move to different areas of the value chain, either be like a key supplier that's designed in, or trying to move up to like a lead system integrator role where you're actually looking at like something that's coming out of Anduril is actually part of a broader network of things that you're responsible for. So those are the two primary reactions. I think, like I said before, you're still not seeing companies go out and invest tons and tons of capital. I see them requesting it from the government more on some of these places to be able to ramp up. But it's interesting to see how this is all playing out.
Got it. And Jason, I think you mentioned a few pieces about like the elements of supply chain and kind of how different pieces of this really fit in and how they impact. Obviously, those newcomers are kind of more like top down, trying to enter the marketplace. Where do you see kind of, again, those established players and the competition really like shaking out in the new market?
You know, in some places, the established players are starting to acquire some of the more interesting people that have been going through and developing and coming up with some of these great new resources. But at the same time, it's forcing everybody to become more nimble, right? Like it's changing. What we're seeing with the autonomous devices, it's changing what we thought we needed to be effective out in the world. And some of the global conflicts that we've seen play out, you're seeing these devices be very effective. So it's no longer just this in a textbook, it should work. They are working. And so now some of the more established players are getting further and further into some of what you've been seeing on the cutting edge from some of these smaller companies. The other thing that you see is the established players, like when they come up with a design, it doesn't change as fast as what we're seeing from some of the newer players. And the established guys are learning that they're going to have to continue to change because we are just scratching the surface of what we can do with some of these autonomous devices.
Got it. Yeah. And Chris, I'd love to get your take kind of from what Jason said, a bunch of, there's these new players coming in, but there's also this increase in conflicts and really like an increase in the, frankly, the market signal that you're getting back as a,
Exactly.
how have you seen folks, really respond to that, both kind of on the business side and on like what you guys need to provide in terms of, what people are looking for to implement at their, at an organization level?
Yeah, absolutely. To carry on to what Jason and Ben were saying, the big dividing line we see, and I believe it was Ben that actually mentioned it, is this division between the high complexity, low volume folks, the established players, and they have what's called a TRL or a technical readiness level. And so there's this desire on the established players to say, we don't want to go to this new technology because now we have to go backwards, requalify, reestablish our technology capability. And so you have these designs that are almost stuck and can't advance to the new technology, the advancements, the shrinking, the embedded componentry, and so on, where you've got the new entries, the drones, the autonomous vehicles, all these new things that are taking advantage of the latest and greatest technology. And so that's one of the big challenges we are seeing is that these high complexity designs, the complex nature of these new designs almost required this new level of technology, but the desire on those organizations is not to use the new technology because it's not as qualified and not as technically ready. And so there's this continuing struggle for how do I achieve this kind of high performance but using my established qualified technologies and designs and circuits and so on. And in that regard, you're starting to see the new players actually starting to get into some of those markets, not quite to the F-35 and submarine level that I believe Jason mentioned, but you're starting to see these new players coming in and starting to edge out some of the established guys because they can meet those performances and so on and get there faster and quicker and higher volumes and so on.
Yeah,
That's
the
one of the big
level
challenges.
I mean, building on what you said, I totally agree. And if you look at some of the challenges that Lockheed Martin has had with releasing, the TR-3 program for the F-35, it's a system of systems type thing, and it's so complex with everything having to work together at the same time. The investment in, hardware, software, the government's, appetite for requirements change, like all those things have to happen simultaneously, which is extremely challenging to do for those systems. And if you think of some of these drones, like they're not that complicated in the grand scheme of things. And, you can be very intentional about the design parameters that you want to have generational leaps and when, and align that to what the industry is doing on the technology side.
Exactly. Yeah. Adding on, the capabilities. The one I like to use is for as we keep shrinking the silicon inside of our processing devices, we get such faster and faster signals that we need to start adding termination resistor capability to our transmission lines earlier and earlier, or closer and closer to the pins, and traditional resistors can no longer achieve that in a BGA. So you almost have to go to embedded resistor technology. But yet, that's not an advanced technology that's acceptable by some of the established players. So you have one of these continuing challenges. How do you qualify that and say, I need that for the technology to work, but it's not qualified, so you don't want me to use that technology.
And we're having some of these same discussions with the government side.
Yep.
And all this stuff. I'm like, because they're running into these major obsolescence challenges with some of this other stuff too, of how do you manage obsolescence in a world of which the technology is advancing faster than you can come up with requirements.
Yeah.
Exactly.
So, how are you purposeful about modularizing your designs and purposeful about matching the technology trends into your requirements from the get-go?
Yep.
So it's becoming a huge problem.
Yeah.
And it again goes back to supply chain, right? So if you qualify this design with this part on it, by the time you get through all your certifications, you get everything done, they're low volume. Do we keep making that part? And so it's a challenge.
Yeah, that goes back to something I ran into when I was at one of the defense contractors, where we literally had a supplier say, yes, we'd really like to do that, but you're only going to ever buy 5 of these. It's no longer in our cost benefit to us. It's no longer beneficial to us as a supplier to supply you 5 of this old part, or 10, or even 100, right? They're looking to do volume.
Yeah, or yes, we will make it, but you'll get it 2 years from now when we find the time.
Exactly.
And these drones, they're so cheap compared to the manned predecessors, that success is measured totally different, right? You don't want to lose one aircraft with a human pilot in it. These cheaper drones, if it gets taken out, it's not as devastating, and so they're not measured the same way. So there's a lot less cost involved.
Yeah, it seems like that modularity kind of at the market level and then at the manufacturing level is really getting translated. Where do you guys see kind of those processes getting pushed into these companies as far as making these elements more modular in terms of the way that you respond to the market? Have you guys seen any design or requirements methodologies being implemented, any kind of in order to keep up with that space? Have you seen any of that? I guess, Chris, I'll start with you.
I'll say what I have seen has been more on the manufacturing side, taking a cue from the electric vehicle market. I've seen a push where, as we said, the time it takes to go through a proper full military level qualification, IPC class 3, et cetera, for a production run became prohibitive in time schedule for the volumes that we're needing to build. And so what the automotive guys started doing is saying, we're going to qualify the process at this fabricator and say, we know you meet all the class 3 process capability, but we're going to let you do a lower level of inspection, a smaller lot size, so we can get through the qualification and testing and certification faster than trying to do like 100% testing like we normally would in military. So there's techniques that are trying to be implemented to try and improve the throughput time and so on. Also, from a design point of view, we're again seeing more of this, at least I'm seeing from some of the folks I've talked to, this desire to try and pre-qualify some of the design processes so we can say, like the embedded resistor, is there a way to go in and build some test specimens to prove that this technology works on a broad scale, so now we can use this resistor the same way we would any off-the-shelf through hole or surface mount resistor part rather than treating it as part of the fabrication process. So those are two trends I've been seeing. Curious to see what else is being said.
What about yourself, Jason? What are you seeing kind of on like those processes that are scaling? You mentioned some kind of like flexibility in terms of what you automate and how you get faster there, but love for you to expand.
Yeah, so one of the things that we've seen, some of the traditional players, they have design companies and then they have manufacturers. And a lot of times they're so separated, design comes out, it's got to get socialized and eventually funded and all that kind of stuff. So the first prototypes are made in one place, and then when funding actually happens, it would be many years later in some cases. And then all of a sudden you get into the manufacturing world and say, oh, well, we can't do this, we can't do this. And so now you're scrambling to try to figure out how to get this through the certification process. But we're finding that our customers are getting more and more engaged with us earlier on in the process, right? Allowing us to say, okay, well, what's the future going to look like so we can reduce the number of spins, reduce the number of time from idea to full production, and involving us sooner, allowing us to work directly with the designers, right? It's a big piece of how we provide value is decreasing the amount of time it takes to go from design to full production.
Yep. And Ben, anything to add
Yeah.
on top of that? And in
I
terms
think just the trend towards an increasing reliance on COTS, commercial components versus like exquisite design chips or special stuff. I think there was always a desire to go beyond anything commercially available for some of this technology, and then it becomes like impossible to sustain coming after it. So, and frankly, the commercial technology has progressed so much that it's even leading edge anyways. So I think both the inclusion of COTS in the designs, plus I think there's a bigger appetite to qualify alternatives sooner for some of this stuff, from even just a supply chain resilience standpoint, to say like, hey, there's not just a one chip or one resistor or one thing that meets this requirement. It's like these 2 or 3 other options. So if we need to switch it or we can, there's a mechanism to be able to do that, which not only helps sustainability, but also helps with cost too.
Mm-hmm.
That's a big one.
Yep. I would concur wholeheartedly. My time in industry, we have to use almost exclusively mil spec qualified parts to we can only achieve this with COTS parts. So how do we qualify that? Now the challenge we had with COTS parts, and this is another supply chain related issue, was ensuring looking for counterfeits. How do we get counterfeit mitigation of, or gray market, black market type of devices? But other than that, yeah, the ability to use the COTS parts and still meet all the design specifications was definitely a cost savings for us when I was in design.
And really looking at those parts that are causing you issues, right? Like in the connector industry, for example, for years, there was 1 or 2 connector companies that most of our A&E customers used. And because they were so challenging in certain circumstances, you've seen all these different offshoots spring up. And the government and these different companies are willing to qualify these guys because they recognize I cannot be beholden to this one guy telling me, oh, your lead time just went from 1 year to 2 years.
Yep.
Yeah, I think you guys are building my segues for me here. Because in kind of offshoot from that, with the new administration, we're seeing a lot of focus on just this concept of efficiency, this concept of how we kind of like get more lean and how we do more with less. You guys were really just pointing out so much of the impacts of those lead times and those suppliers. Where do you see other opportunities for really streamlining efficiency in the market? And Jason, I might whip it back to you.
Obviously from the manufacturer's perspective, they're everywhere, right? We've been really pushing on our side automation that not only drives a more consistent result, but reduces cost, right? Instead of every time an operator needed to move a part from here to there, whether it's just going straight through conveyors that are much more flexible than they used to be, whether it's robotics driving parts from place to place, but getting more consistent information faster using the automation is a huge part of the advancements we're making in manufacturing. And that's going to drive down cost and drive up reliability. So those are two
Mhm.
big ones from the EMS side.
And
Yeah.
where do you try to kind of focus in terms of making sure that those choices that you guys make for upgrades are like leading towards that efficiency? What kind of markers do you look at?
We're trying to see what is the most challenging parts of our process, right? Obviously, surface mount gets a ton of attention because it's such a big part of every single circuit board. So the surface mount advancements that we make, we rely a lot on our partners. Where is the industry going? Our partners, we hosted a manufacturing days here a couple weeks ago where we brought all seven divisions in and brought in some of our best partners and said, okay, tell us the latest and greatest things that your equipment is doing. How can we better utilize what you're currently manufacturing? How can we be better users of your equipment? And our partners help us a lot of seeing what's the next thing that their technology is able to handle and how do we implement that to provide a more quality product with a faster throughput. So it's not about volume, right? In this game, we're not trying to place millions and millions and millions of parts faster. We're just trying to run more efficiently, right? Keep the machines running, keep them running in an efficient manner. If they're shutting down, it's bad. What happened? Why? How can we be more consistent? And that's what the automation does for us.
Excellent. And
Yeah, it's,
yeah,
I was gonna say automation on the manufacturing side. On the design side, we're starting to see more and more integration of AI into design to help speed up the design process, but we're also seeing more uh, collaborative integration, especially in the ECAD, MCAD side of things. One of the places we always struggled when I was in design was we ECAD designers would sit there and do our design, and then we'd have to pass the design over to the MCAD guys and go back and forth, trying to get, the whole product design. We're starting to see now many of the different CAD tool vendors actually integrating and having collaborative capability where in almost real time, you can simultaneously design the MCAD side of the world and the ECAD side, get the mechatronics, get the environmental simulation, the thermal and structural and vibe and shock simulations all done at the same time to really speed up. So you've got hopefully a single spin cycle or very low cycle in prototype to production ready designs. So that's the other place that I think we're going to see a lot of improvement in efficiency is getting that collaborative design, getting that integration on the design side, in addition to the automation that we're seeing on the EMS side of the world.
I think going back to the administration point that you made, Caitlin, you're seeing some of the CEOs and other spokespeople of these companies coming out more visibly in areas to reduce costs. Chris Kubasik, who's the CEO of L3 Harris and the chair of AIA, wrote a letter to Doge, I think last week or 2 weeks ago, around just areas that they see efficiency that are frankly painful to a lot of these established players. Things like, dealing with cost accounting systems or the way contracting works or qualification for or overqualification requirements. A lot of these things that have traditionally driven up a lot of cost, but also a lack of incentive to invest back in the business. And that's really the conversation that they're trying to have is, hey, if you change the way that you contract or allow us to make investments ourselves and get return out of it, you're going to see a big step change in industry capability. Because right now, if you think about cost plus contracting, and even some of the way that they're negotiating fixed price with TINA and cost visibility and fixed margins and all those things, that somebody like a Lockheed Martin or a Raytheon is going to say, hey, why would I make this huge investment in my business if you're going to give me 12% ROS? Like, it just doesn't make sense.
Mm-hmm.
So you're seeing that mind shift switch a little bit, and I'll be really curious to see how that plays out, because that could have a big impact on how the industry functions.
And I'll say it's not just financial cost, it's schedule cost as well, because I ran into the same thing. It's, not only was it financially prohibitive, but it was, okay, I'm going to spend the entire first year of my contract just working out scheduling and contracting and finances and all before we ever do the first bit of the design for a
Well, maybe you
product.
look at a submarine, totally to that point, if you look at a submarine, you get the first one rolling off the line and you get obsolete parts on
Hmm.
it. It's like,
Yeah,
Crazy.
exactly. It's like,
Yeah, and Ben, I'd love if you expanded a little further on that letter because I thought it really highlighted kind of elements where the government necessitates this overhead, which that leads to elements of inefficiency that is quite difficult to come out with on a cost side. Are there any other areas that you would expand upon there to kind of like add to where those areas really lead to process that ends up not being as much value add?
yeah, I mean, I'll give one example. For instance, if you think about, there's just an inherent lack of trust in the industry, and it's, I'll call it a overabundance of creating rules for the exception. And if you create rules for the exception and complete lack of trust, then you have this huge amount of oversight on both sides, like both from a government level of, somebody at DSCA or whatnot that has to go justify their job and go find something that's wrong, versus like all these people in industry that have huge compliance teams that have to go make sure that they're satisfying all of these. And you end up with this very long process and very high level of overhead on both the government and the industry side to even do this. I mean, if you think about cost accounting systems, for instance, there are several defense companies that have multiple cost accounting systems and multiple cost pools within their business. And they've got to have finance people that overlook them. They've got to have auditors that go audit them. They got to have external auditors that go audit them. They've got to have separate ERP systems. They can't share resources easily across those things. And these are all just huge inefficiencies in the industry that really benefit nobody in the end.
Lots
And
of
Jason,
red tape.
hmm
I mean, on the plus side, if you're in the defense industry, and it's been a huge barrier to entry for folks. So you don't see a lot of new entrants coming in there. And a lot of the reason that Anduril's been successful is the government's, been able to go through alternative contracting methods like DIU or OTAs that allow them to do business differently. So if that continues to progress and become more available for traditional procurements, you might see a change faster.
absolutely. Excellent. Well, kind of on that same line of just thinking about process and the way that folks work together, as we see the market changing and how we kind of hear that concern of like elements of this old business versus the new, we also hear this element of kind of, a tribal knowledge being lost in the next like 15 years, like having elements of certain folks leaving and certain folks coming in. And like you have pointed out, the cyclical nature of defense often means that kind of people who learned lessons in the last high time are not necessarily always around for the next one. In terms of kind of like making sure that that exists within a company, where do you guys see pushes to software to fill these gaps? Or where do you feel kind of like hiring, training, kind of like new elements that you can bring into the business would really help facilitate that transition? And Chris, I'd love to kick off with you.
Sure. So we see that quite heavily. That's actually one of the reasons why I created the courses that IPC created the courses that we did specifically in Mil-Aero courses. We have a number of students coming in every time. It's one of our most popular courses on, yes, I'm going into this and I need to learn how to design for military and aerospace, A&D type of organizations. We also see a trend now in industry, especially in aerospace and defense, in apprenticeship, workforce training and apprenticeship programs to try and encourage the younger generation to join and work on those type of designs, as opposed to going into commercial or industrial or consumer goods or whatever the case is. So those are the two areas where we see a lot of push from the industry, recognizing that, saying, hey, we need some workforce training, and hey, we need to send our people to training courses specifically in order to learn how to do these designs.
Could you elaborate a little bit more on the topics that you see folks really like diving into internal to that?
Yeah, a couple of big ones that I get all the time are how to do the high reliability design. So, what does it take to build a high reliability product that will succeed the first time in a timely manner? A lot of folks come to the class and say, "Hey, I did this. I tried to build the way I used to, and it failed. We had to do eight or nine spins of a board before it finally worked and passed qualification." So we get a lot of high reliability, and we get a lot of security slash call it the almost the accounting type things, like how do you meet ITAR and all these other regulatory compliance that aren't necessarily designed but are necessary in order to be successful in this market. So there's a lot of like you said, lack of tribal knowledge or loss of tribal knowledge in that regard. And so we try to put training classes together that cover that information.
Got it. And Ben, I'd love to get your take on that. Kind of how do you see folks transitioning elements of their workforce in both the last, 5 years and the next 15, planning for it?
I think there's a lot more rigor in documenting standard processes for a lot of this stuff, especially on the production side for building it. If you walk into some of these defense production facilities, it's more art than science for a lot of them, especially if you think about like space applications or protected communications or, things that involve glass and electronics and all kinds of like really crazy designs type things. So making sure that they're documented or even just moving designs away from it. But if you think about a lot of the environmental concerns, and not environmental from like a climate standpoint, but just like operating at altitude or operating under the water or operating in a contested environment or operating in space. And like these are not things that your normal commercial engineer has to deal with. So, making sure, like Chris said, the apprenticeship programs, the documentation of what it takes to go do it, the experience of working with other folks and talking to customers about the challenges that they have is really important.
Do you see any recommendations kind of for like, you mentioned kind of like codification of those inside of standards. Do you see any places where software or kind of like digital transformation are being used to assist with that?
Yeah, we've seen, I'll call it like visual tools out there, both from a production and inspection standpoint, some of the stuff that Instrumental's doing, frankly, about like if you took an operator that was really good at making something, take something that's like incredibly difficult to make, right? It's like traveling wave tubes that do communications from space, like being able to document visually operator doing that operation and translating it to a work instruction using like an AI tool is really cool to see that progress because it can pick up on nuances that you may not see otherwise.
Mhm.
Jason, I'd love to hear more about how you guys are thinking about that. I know you recently added a new design facility and that you guys think about this a lot. So, yeah, how do you really think about those next steps, both in the last 5 years and then again, the next 15 in terms of how to make those transformative choices?
Yeah, we're seeing a ton more outsourcing where typically companies would insource, right? As you described, we've got a design arm now that is continuing to grow at an incredible pace because these companies don't have the engineers available. They have retired, they are moving on. And so while you can't outsource everything, they're challenging what they can outsource and they're adding more and more into their platform of what they're going to buy versus what they're going to build. And having partners that they trust that, hey, this guys have been doing high reliabilities for decades. They've given me several projects in a row. Let me give them that next one. And we just think it's going to continue to grow exponentially. And so we've been investing in more and more in some vertical integration, whether it's a cable shop, whether it's design services, and being able to provide a full service for all of our customers from design all the way to shipping. So we think as the world progresses, there's going to be more and more outsourcing of things that were traditionally done in-house because you just don't have the people or the talent to be able to carry on what you used to do.
Yeah, and within those automations and software and, like kind of just the general theme of trying to do
Yeah.
more with, where do you really try to make choices about those next steps for both what you see in the market and how you kind of see it, yeah, how you see it moving?
It's from start to finish, right? Having the proper ERP system that's allowing us to grow and communicate effectively with not only internally but externally, whether it's vendors or customers. Those pieces, traceability systems on the floor, being able to provide the top end traceability down to the reference designator, really being able to tell the customers all the information they need so they have the trust that you're building their high reliability products properly, right? It's a lot of trust to choose a partner that says, okay, I used to do this thing, I made this thing in-house, I'm going to transition it over here. How can we give them the information that they need so they can continue to see that same level of control that they had when it was internal, now that it's external? And those systems are a really important part of our communication with our customers.
Yeah, and I think Jason, I forget if it was you or Ben that mentioned that element of trust, kind of like working together, and that process is really codified throughout
Yeah.
because of the lack of trust. And in terms of like building that up more efficiently through that method, it seems like a pretty effective approach. Ben, have you seen something similar?
Yeah, I think the thing that I'd like to add to the conversation here is I see a lot more conversation. I mean, if you look 20 years ago, it's, how do I design and make a product that's going to last for as long as I need it to for this span of time? So like an aircraft carrier, like there are things that were designed on the aircraft carrier that are life of ship, like 50 years. And we're finding out that they're not. And all this stuff, and it's becoming very challenging to design these type of things that have unique requirements. And it's shifting more towards like, okay, we know we're going to replace these things. Like, what's the cycle that we should replace them into something that's more traditional for how long it should last? For those type of environments versus designing something specific. And then I think they're like having the real conversation of what's an acceptable level of failure and what does failure really mean and what's the impact of doing it. I think there's been this like zero failure mentality, and God forbid you fail one in the field, you're going to have to put in 10 times the amount of testing you had previously because you had one failure. Whereas if you took the approach of really defining like what an acceptable level of failure is, what's the impact of that failure, like a FMEA type thing that you would do, and making sure the cost benefit analysis is really in place to those requirements in the first place.
Excellent. Yeah, and Chris, anything to add to that?
No, I would concur with what Ben said, especially as we get longer and longer product life in more and more of these extreme environments. Yes, the like satellites are another great example in space applications. Like, yes, we're going to put it up there. It's not easy to replace it or repair it, so it does have to have high reliability, but we also can't expect the thing to run for 20, 30, 40, 50 years. So we know that technology is going to increase, advance, capabilities are going to advance. So it's like, okay, rather than designing this super high-end satellite that's meant to run for 40 years, we'll put a 10-year satellite up there and just build the next generation one, kind of like what Starlink is doing with theirs. It's like, yeah, we're just constantly launching a bunch of new ones. Okay, one just fell out of the sky, put another batch of them up there. I think, yeah, we're done. To Ben's point, it's like as you're trying to build these longer and longer life cycle designs, aircraft carriers, fighter jets, whatever the case is, the nature of what we build is that you cannot get those kind of lifetimes out of it. So we have to be able to treat it as acceptable repair, acceptable maintenance, acceptable levels of repair, replacement, failure, etc. Yeah, and I've seen the same problem, the zero failure mentality. Oh, I had one failure 15 years ago. Now I have to do an extra, 3 months of testing and qualification on one board. I'm like, really? Okay. Can you afford the schedule on that, guys? You want to, get a whole bunch of stuff out to the customer. So, yeah.
I've seen that like 100 times.
Mhm. Yeah, I lost count. Yeah.
Yeah. It's like,
Well,
oh, you feel group C? Yeah.
you see these requirements, some of them like you can't even trace it back to that failure, right? Like, why is this requirement in place? Well,
Hmm.
this guy 3 guys ago put it in place because something bad happened. We're not even sure what it really was, and
Yep.
does it still make sense or not, right? It's a huge piece of where we need to go.
Mhm.
Yeah, absolutely. All right, excellent. Well, I wanted to leave a little bit of room at the end here for questions, just kind of from the audience. So I'm thinking that they will come up in the chat window here, which would be great. Um, give it a 30 seconds to kick off. Never mind. I might just do my own question. So so we chatted
Ben did such a good job of explaining.
Exactly.
um Perfect. Well, I kind of wanted to get the group's take. We alluded a little bit to this notion of, I'll do that in a second. We Great. We kind of touched on it a little bit, but this idea of variable versus fixed cost. Out of curiosity, we talked a little bit on the surveillance side and elements of that really going to more to a fixed cost model and certain businesses going in that direction. Out of just your own thoughts, with respect to the modularity you see being increased in some of these more complex designs, where do you see that really going next, in terms of like the various assemblies that we just chatted about that are quite a bit more complex? And Jason, I'd love to kick off with you on that one.
Yeah, again, I think it all goes back to supply chain, right? And fixed costs, they work for certain pieces when you control certain parts of the supply chain, but as other pieces are designed externally and you're trying to control those costs, fixed cost systems end up hurting you more than they can help you sometimes. The other thing is you're not going to take the benefit of, as you improve and get better designs, the decrease costs in manufacturability. So the fixed costs are hurting you on that side. So I think it's a model that does not drive for the best possible product.
Mm. Yeah, I would agree with what Jason said on that. Uh, the times we worked on fixed cost models versus cost plus or some of the other ones, the fixed cost models always had, uh, at least in my experience, the worst performance out of the design cycle compared to some of the other cost models that we used for exactly the reasons Jason mentioned.
Yeah. And Ben, would you agree?
Yeah, I agree. I mean, I think until you change contracting, even industry into supply chain and giving more visibility into out years, you're going to have a challenge making the fixed cost model work, or at least give somebody a return for putting that fixed cost in place in the first place. So, I mean, there's a lot of benefits to it. If you think of like automotive, for instance, there's a ton of fixed cost, or a ton of capital put into these things. But the volume and the longevity for what they plan for makes it make sense.
Absolutely.
Yeah.
And then I'd love to kick into the next question, which I think we've touched on a fair bit. Kind of, Jason, you touched a ton on supply chain and elements that like we do or don't control outside the US. Obviously, a ton of the componentry that we're talking about in consumer products is built outside of the US, all the way up to PCBs, even entire assemblies. How do you guys think about where that relationship stands within aerospace and defense and how to work with people most effectively on that?
It's evolving, right? A lot of these traditional parts were made overseas, and I don't know how much you'll see some of the traditional components coming here. I know we're building some factories, and it takes a lot of volume to make component manufacturing profitable. So I'm curious to see what that will look like. But for the PCBs themselves, we're starting to see a lot of that come back to the United States. There are some really great players here in the U.S. that specialize in this type of work. You're going to pay for it, right? It's going to be more expensive, but it's still worth it when it comes to the fact of I know it'll be there when I need it. You're seeing different companies validate, okay, you can use any one of these 4 PCB houses. In the past, it used to be, well, you can use one. And so
Mm.
they controlled all the costs, they controlled all the timing. So we're seeing a lot of transition away from sole sourcing and to anything that's not China. We get pushed a ton for what could you offer as an alternative that's not China. So some of our design services are specifically that, just redoing a bill of materials to try to find alternate sourcing from different countries that have a friendlier government.
Yeah.
Yeah. And Chris, yeah, what have you seen kind of on that same regard?
So similar to what Jason said, but the other thing I've seen in my experience was you also have partnership and trust agreements with certain tier one distributors from the supply chain that have the agreements in place for the ITAR, for the anti-counterfeit, and so on, that says, I'm ordering from the supplier, and I'll use a couple of examples here in the States. We have like Aero, Avnet, Allied. We're a couple of the big three players, Future Electronics, you know, that used to be these big tier one distributors. You say, okay, this is for the military, so I need this part, but you'd have agreements with them that they would only supply it from their distribution sources that are not in the conflict areas like China or other locations like that where we might have some less than friendly relationships and so on. So you'd have some of those established distribution chain partners or supply chain partners that have the capability to do the counterfeit resolution and mitigation, the distribution supply chain. In fact, I'll give you a perfect example. We had a resistor part, and that manufacturer had a factory in China and a factory in Malaysia. And we said, we want this part, but only the ones made out of Malaysia. So they went through their supply chain, said, here's the supply code. Okay, we're only going to ship you the ones that came from Malaysia and not China, kind of thing. So yeah, you can have those agreements within supply chain with your distribution partners in order to help mitigate those to meet the needs of aerospace and defense and, you know, security and reliability.
And Ben, where do you see that really shifting kind of at the organization level, like kind of either bringing really just changes in deltas, kind of like either seeing more outsourcing or less, or kind of, yeah, bringing it onshore versus not?
It's a really complicated problem. I see the primes especially going after and having suppliers certify that none of their materials are coming from China, even all the way down to the raw material. Even things that come through non-China countries a lot of times start in China. So, figuring out how to get to the root of that is a really big challenge for a lot of folks. I think it's less of a outside US problem and more of a China problem right now. If you listen to anything that's come out of Congress lately, I see a lot of multi-sourcing happening where you've got volume coming from a place like Korea, especially for raw PCBs, and doing some sourcing in the US or Mexico too. There's a lot of consolidation happening even in the raw PCB space happening in the US. You see some of these suppliers putting investment here to grow capacity and capability, which is great and good to see. It's never going to be cost competitive to overseas. So making sure you get your strategy right when going through this process is really important.
Absolutely. And to expand on what we were talking about earlier with respect to transparency and kind of that like trust that needs to be established between the DoD and the government and the players who are trying to communicate and really, bring services to them. What do you think should be done at a higher level there to expand visibility? And Ben, I'd love to start with you.
I think there's this desire out there, or maybe there's just a notion that the defense companies are set up to fleece the government and fleece the taxpayer. So part of these regulations are to increase visibility, which is actually creating a problem. I think the theory behind a lot of where the companies are trying to go now is the market forces themselves end up regulating the industry and creating requirements from the government level that increase and incentivize competition for a lot of this stuff will in of itself create the right set of incentives for companies to either invest in these places or drive prices down to make them advantageous for the taxpayer. So, I think this desire for let's have everything open book and making sure you've got auditors and auditors of the auditors and auditors of the auditors of the auditors. I saw an instance where there was an audit firm hired to get ready for the other audit firm coming in. And I was like, what are we doing here? So I don't know if visibility is necessarily the answer, rather than creating the right set of requirements and expectations that drive the right behavior in industry.
Yeah, absolutely. And Chris, any additional thoughts on that?
I would wholeheartedly agree with what Ben said there. Again, too much visibility can be just as detrimental as not enough. Too much visibility, you get folks who don't necessarily know all the nuances of our industry telling us how to run our industry, causing more of these regulations and problems and so on. And instead, as Ben said, we should hopefully have incentivize the right set of requirements that will in turn make it advantageous to meet these type of cost benefits for the industry.
Yeah.
And Jason, do you feel similarly?
Very, yeah, that natural competition drives the right decision making. If you look at what's happened in the space industry, as some of these commercial companies have come in, it's driven the costs down. It's driving the behavior we're looking to have happen. And you're not going to get it by straight oversight, and adding more oversight to more oversight to more oversight isn't going to do it. It's competition.
Mhm. Yep, absolutely. And then last question to close out. What do you think are the most promising advancements for inspection, quality control, kind of automation that could really impact these production timelines that we're looking at? We've talked about kind of the implication of these really long timelines throughout the chat. Where do you think you see the industry shifting and advancements there? And Chris, I'd love to start with you.
So one of the ones I saw just recently in a different webinar was advances in 3D microscopy. I can never say that word. Basically, the automated CT scanning, where instead of a CT scanner, you've got the movable optic head that can zoom in on the small areas as well as get the large areas and get those full 3D scans as we do more and more bottom termination, where the entire solder joint is completely hidden from traditional optical view, and relying on traditional X-ray inspection just does not give you the detail you need to know that you've made good connections. So being able to do those complete 3D inspections through the entire structure of the device, the board, the entire structure in an automated way, I think is very promising from an inspection point of view. And then again, just reiterating what Jason and Ben both said earlier, just advances in automation, keeping those inspection machines running 24/7, automated loading, automated testing, speeding up the testing, and possibly having some AI maybe added in to add efficiencies in the test sequence and what actually needs to be tested to show full compliance, right? Rather than going back and measuring every single resistor in, say, a chain, is there a way to automate testing the entire chain and getting a different reading to speed up those processes?
Excellent. And what about yourself, Ben?
I'd agree with that. It's an adequate question to end the instrumental webinar with here. But adding the visual inspection, a lot of the AI based things with super high quality cameras and other sensing tools that can really get to root cause is promising. I think the thing that we've been able to see is moving the testing back up the production process earlier in the production phase. A lot of times you see testing way at the end of an assembly, and then there's so many things that could have gone wrong by that point. And you have to do you're basically doing full functional design testing at that point, that it just takes such a long time to both conduct the test and actually debug it at the same time. So, being able to do those tests earlier on, or even just get evidence earlier on of where there might have been a problem and correlate it back to the test that happens at the end, are hugely important.
Yeah, and Jason, anything to expand? I saw you nodding.
Two major points that Ben just made that I think are crucial, right? So moving it further up the chain, right? Solder paste inspection's been around for a while. It's the first part of S&T, but it's come such a long ways that we're getting such a reliable result now that we got good data. 5 years ago, we were having the machines flag and say, hey, there's a problem. Technician can come up and they can make a change. So we're finding it sooner. But now what's happening is we're using automation to just automatically change the equipment, right? Getting the machines to be able to accurately flag there's a problem. And instead of calling somebody over, which slows down the process, is more inconsistent, just automatically making the changes inside of the machines. And so driving that earlier and getting more resolution on those changes, and then also having the data behind it. We've talked a lot about trust, right? When our customers come to us and say, I think you did this. Can you show me here? Having the serial number going down to the individual pad. Well, I think this BGA might not have had a good connection at row 4 or 5 over, and showing, well, this was the SPI result for that serial number at that pad. This is what it looked like pre-reflow. This is what it looked like at SPI. This is what it looked like at AOI, X-ray, giving them all that information so they can see what is and is not going on, and being transparent, showing them that information. So getting better inspections sooner and using the automation to get a more consistent result than we've been able to previously has been a big part of that for us. So I think that the next place is conformal coat, right? You've seen a lot of these companies use a parylene coating, right? Because it covers everything, but it's really hard to work with. It's impossible to rework, right? If we can get better conformal coating processes and use automation to be able to inspect that, to make sure you're getting a good coverage, you're going to have a better product. Parylene, it is what it is. It's been around for a long time, but there's better coatings out there, but you just can't prove the same coverage you can with parylene. So using the inspection technologies to be able to take conformal coating to the next level, I think is going to be a big one for us.
That's a great place to end off. Thank you so much for your generosity in participating. Jason, Ben, and Chris, you guys were excellent panelists, and looking forward to keeping in touch with you guys. And thanks to all the attendees for joining us. Have a great day, everyone.
Thank you.
Thanks, Caitlin.
Thanks.
Everybody.